Hello all, welcome to this session of Class 9 Mathematics and I am your Anu from MathSchool.1. Today it's going to be a continuation of Chapter 7 Triangles and we are yet to complete two other congruence criterion, and today we'll be seeing side congruence criterion. That is the simplest of all the 5 criterions. Okay, so let's directly move to the problem and let us understand the criterion through the problem itself. Okay, so the first problem says ABCD is a parallelogram. If the two diagonals are equal, find ABC. So we know that in a parallelogram, opposite sides are parallel and equal. It's just like a, you may take it as a rectangle, right? Rectangle, opposite sides are equal and parallel to, right? A parallelogram. A rectangle is also a parallelogram. A square is also a parallelogram. Now we'll start doing the problem. Now we have ABCD is a parallelogram they have given here, right? If the two diagonals are equal, you need to find the angle ABC. Okay, you need to find the angle ABC. Now what is given here? The diagonals are equal. So what is given? First let us take down what is given. AC is equal to BD, right? The diagonals are equal. So the first thing we need to do is we need to spot two triangles with these diagonals, because we are given that the two diagonals are equal. So let us spot two triangles with these diagonals. Okay, so see, BD is a diagonal here and AC is another diagonal. So since BD is here, I am taking ABD as one triangle and with the same base ABC the other triangle. Okay, by taking out two triangles with the same base, we have one condition, that is one part. Out of CPCT we have 6 parts, isn't it? For corresponding parts of the congruent triangles we have 6 parts, and out of which one side will be equal if it is taken as common side, right? So AB is the common side for both the triangles ABD and ABC, right? So I am taking triangles ABD and triangle ABC. Okay, so in these two triangles, if I try to prove that these two triangles are congruent, then we'll have some parameters of this parallelogram to be equal, right? Then we can move on to solve what is the measure of angle ABC. Now we have ABD triangle and ABC triangles here. Now we have, first thing is the side which is common. AB is equal to AB in both the triangles. See, AB is common in both the triangles, right? Now what about BD? See, BD and BC. What about BD? What about BD here? See, we have written A, B, D, right? Like that we need to write. Okay, let me write it properly. B, A, C. Now AB is equal to BA, that is the common side. Next, in this, what is BD? BD is equal to AC, right? Because both the diagonals are equal, that is given here. So BD is equal to AC. So this is common and this is given. That is, both the diagonals are equal, it is given here. And since they have given that ABCD is a parallelogram, opposite sides are equal and parallel, right? So AD and BC. What about AD and BC? So those two are also equal. That is, AD is equal to BC. So which is also a given condition that it is a parallelogram, right? So see, 3 sides are equal here. So according to side congruence criterion, we have 3 sides of the corresponding, 3 sides of the corresponding triangles to be equal. Therefore, we can say that these two triangles ABD and BAC are congruent. Okay, so thus by SSS criterion, we can say triangle ABD is congruent to triangle BAC. So this is how we prove two triangles to be congruent with the help of side, side, side. That is SSS criterion. Okay, so now we have proved both the triangles as congruent, right? Now, how do we find out the angle ABC, the measure of angle ABC? For that, so now since we have both the triangles to be congruent, I have, according to CPCT, now according to CPCT, angle ABC, see here angle ABC, this angle is equal to angle BAD, right? Angle ABC is equal to angle BAD, because the angle, the corresponding parts, see in this triangle, this angle, and in the triangle ABC, the angle ABC, they are equal, angle BAD, according to CPCT, because these two triangles are congruent, so the corresponding parts of the congruent triangles has to be equal, right? So angle ABC is equal to angle BAD. So up to this will be, we have taken from the SSS criterion, right? So we'll move on to the next part of the question, that is, what is the measure of ABC? Now we need to find the measure, that is in degrees. We need to say what is the measure of ABC. So for that, what do? We take the first sentence, ABCD is a parallelogram. So in a parallelogram, we have opposite sides to be parallel, right? So I take AD parallel to BC, isn't it? So AD, since AD parallel to BC, whenever we see two parallel lines, we can search for another line which is crossing those two parallel lines, which is nothing but the transversal, right? So AD and BC lines are parallel, and we have this AB to be the transversal. Because why are we concerned with this particular line AB as transversal? Because we have many other transversals for these two parallel lines. We have AZ is a transversal here, then BD is also transversal, and CD is also transversal. But why do we particularly take this AB as transversal? That is, from that point of view, why do we take AB as transversal? Is we are just concerned with the angle ABC. Right? So the angle ABC is on the line ABC, on the line AB. So we consider the transversal AB for these two parallel lines AD and BC, right? So AB is the transversal here. So these two parallel lines and the transversal here, so we have set of angles, isn't it? So here in this angle BAD, that is this angle A, and angle ABC, this angle B, how they are related? In that there are two parallel lines and the transversal is here, and one angle here and one angle this side, that is, they form the adjacent angles, and the adjacent angles formed because of the transversal and two parallel lines are always, what they are always supplementary, or the sum of those two angles will give you 180 degrees, right? So angle BAD plus angle ABC is equal to 180, because they are supplementary, they are adjacent angles. Okay, so we have studied all these concepts in lines and angles, so it is better to recall those concepts so that you will understand it better. So now BAD plus ABC is equal to 180 degree. Now already we have proved by SS criterion, though the triangles are congruent, and according to CPCT we have ABC is equal to BAD, right? So I write ABC instead of BAD. Okay, so I replace BAD by ABC itself. So ABC plus ABC is equal to 100. Because you're concerned with angle ABC, I write ABC instead of BAD. So 2 times ABC is equal to 180 degree. So that gives you ABC, this angle ABC is equal to 90 degrees. Isn't it? So this is 90 degree, and similarly we can prove this also to be 90 degrees, and opposite angles are supplementary, opposite angles are equal in a parallelogram. So 90, 90, everywhere 90 you have. So this is obviously a rectangle. ABCD is a rectangle. So that is how we find out the angle of ABC using SSS criterion. So this is one of the easiest, very simpler criterion than the other ones. Okay, so triple S criterion, SSS criterion is the three sides. We need to prove all these three sides of the triangle are equal. For both the triangles, all the three sides have to be equal, and then we can say the two triangles are congruent. Okay, so do check this problem once again and we'll move on to the next problem. Now, what is the next problem? State. If two isosceles triangles, we have two isosceles. See, from the diagram we can find out two isosceles triangle have a common base. See, BC is the base here. Actually, I have given two diagrams here. There are two separate diagrams, but the problem is the same. And the two, for both the diagrams, the problem is one and the same. We'll see how it is same. If two isosceles triangle have a common base, prove that the line joining the vertices bisect them at right angles. So what does it mean? See, you have two isosceles triangle. Let me name them. ABC is a triangle and the other triangle is BDC. Okay. So since I am naming it as ABC, I'll name this one as DBC. Okay. So ABC and DBC are two triangles. They are isosceles triangle. So both have two sides to be equal. Any two sides to be equal. And they have a common base BC. Now you move on to the next diagram. You see there are two triangles ABC, ABC and DBC. Right. So ABC and DBC are two triangles with a common base BC. And the line joining their vertices. See, line joining their vertices A to D. If I join A to D, okay, so here too, if I join A to D, their vertices, and here I have extended it up to E. So here when I join their vertices, it bisects them at right angles. See, it bisects them at right angles. Okay, so this is what we need to prove, that they bisect. The line which joins the vertices A to D bisects the other vertex, bisects the base at right angles. Okay, so this is what we need to prove. And how do we proceed? So first thing is, we have the the given condition is, it is both the triangles are isosceles triangles. So let us start with that. We have, see, let us take AB is equal to AC here. So what is given? It is an isosceles triangle. So we take AB is equal to AC, and also BD is equal to DC. Okay, BD is equal to DC. Okay, so with these two sides, see, these two sides are equal and these two sides are equal, and this is a common side, AD is a common side. So I can take those two triangles which has all the three sides which we have stated now. See, AB, AC, BD, DC, and this BC common side. So let us take the triangle ABD. Triangle ABD and triangle ACD. Triangle ACD. See, I've taken ABD and ACD. So whatever triangles I spot in this diagram, the same thing can be done in this that diagram also. So you can try with this with the second diagram. So whatever we do with the first diagram, you can try it out with the second diagram also. It will be very easy for you to understand. So now ABD, I have taken ABD and I have taken ACD as two triangles. Now in these two triangles, it's very easy for us to prove the congruency between these two triangles. How? Because we have already stated AB is equal to AC, right? In these two triangles, see, AB is equal to AC, BD is equal to DC, and the common side is AD. AD is equal to AD, it is the common side. So now we have all the three sides to be equal in both the triangles. See, the sides, the three sides in one triangle is equal to the three sides of the corresponding triangle. So according to SSS criterion. So according to SSS criterion, yes, we have both the triangles. Triangle ABD to be congruent to triangle ACD. So now we have proved these two triangles to be congruent, right? So we have proved that these two triangles to be congruent. Now what is the next part we are trying to prove is the line joining the vertices A to D bisect BC at right angles. Okay, so that is the thing we need to prove, right? So for that, what do? We have proved these two triangles are congruent. So according to CPCT, so next step is we should find out all the parts, all the corresponding parts, whether they are equal or not. They have to be equal. So according to CPCT, what we have is, we have these two triangles to be equal. See, 1 is equal to 2. So just for you to keep track of it, I have written 1 and 2. So 1 is equal to 2. And see here, these two angles are also equal, and these two angles are also equal. Just to identify CPCT, so first we know all the three sides are equal in both the triangles, and now we have, according to CPCT, we have all the angles, corresponding angles to be equal. See, 1 is equal to 2, and these two angles are equal, and these two angles are equal. These are corresponding angles, right? So so A is equal to, from this you can say A is equal to A, and ABD, see, ABD is equal to ACD, right? That angle is also equal, and here D is equal to D. So all the three angles are equal according to CPCT when you follow SSS criterion, right? So now what shall we do? We need to find these two angles, and we need to see whether they are equal. Only if these two angles are equal, see this 3 and 4, only if they are equal, we'll be able to say the line joining the vertices bisect them, right? Bisect means the angles are equal and the sides BE is equal to EC. So what do we need to prove? BE is equal to EC and the angles are also equal. Now how do we do that? Since BE and EC, these two sides are our concern, what do? We spot triangles with those two sides, right? Because we need to prove they bisect. See, the line bisects BC. The line bisects BC, right? So we are concerned with BE and EC. We need to prove BE is equal to EC. So what do? We take those two triangles which has BE and EC as its sides, right? So what do? We take ABE and ACE. Now do you follow? We take triangle ABE and triangle ACE. Now after spotting the triangle, everything will fall into place and you will be able to identify the sides and the angles, right? So the only thing is, we need to spot the triangles, the particular specific triangles where we need to prove some parameters. That is, whatever we need to prove, it falls on the triangle. We need to see that it falls on the triangle, right? So ABE and ACE are two triangles. Now what do we have? We have AB is equal to AC, because that triangle, that is ABC, is an isosceles triangle. So we have AB is equal to AC, right? That is given. Next is the line AE, the side AE is common to both the triangles, right? Because ABE and AC have AE as the common side. So two sides, see, this side and this side are equal, right? And we have just now we have proved that 1 is equal to 2 according to CPCT by SS criterion. We have proved that these two triangles ABD and ACD are congruent and angle 1 and 2 are equal. Just now we proved. So we have these two angles to be equal. So according to what criterion it is? Yes, AS, right? Very good. So according to SAS criterion, we have ABE is congruent to AC. Now do you understand? So according to SAS criterion, we have ABE congruent to AC. So how do we incorporate? How do we incorporate both the criterion, SSS as well as another criterion, side angle side criterion, in a single problem? So that comes out of practice. When you are able to visualize See, when you are able to visualize triangles and the corresponding parts, you'll be able to easily find out, okay, the valid points for congruence. Now we have, according to SAS, these two triangles are congruent. So by CPCT again, what do you have? See, already these two sides are equal here. See, SAS, according to SAS criterion, we have two sides equal. So what happens? Automatically BE should be equal to CD. So that is what we are trying to prove, right? So BE is equal to C. So since BE is equal to CD, this line is bisecting naturally, right? The line AD is bisecting BC because BE is equal to CE. So when both these triangles are congruent, according to CPCT, these two triangles have to be equal. 3 and 4 have to be equal. Now what is 3 and 4? 3 and 4 fall on a single straight line. So 3 plus 4 is 180 degrees. And these two angles are also equal because we have proved these two triangles to be congruent. So 3 and 4 are equal, and since they fall on the straight line, they form a linear pair. So 3 plus 4 is 180 degrees. Since they are equal, each has to be 90 degrees, right? So the line AD, which joins the vertices, bisects the base BC at right angles. 3 and 4 we have proved them as 90 degrees, right? So all falls into place when we prove two triangles to be congruent. So our main aim is to prove two triangles which we are which we are concerned about. That is, first thing, after seeing a diagram or after studying about the conditions given, just try to spot two triangles. The two triangles has to have the conditions on it. Okay, whatever given here in the question, see, whatever given in the question, there will be conditions to prove, right? Whenever you are asked to prove something, there will be some conditions. So those conditions has to lie on the triangle. See, they have given you two isosceles triangle, so two sides are equal. So we are choosing two triangles such that we have the equal sides on the two triangles, so that it will be easy for us to prove, right? So see to that you spot two triangles which has the conditions on it, and the condition which we need to prove also fall on that triangle. Okay, so that makes logic, and we'll be able to find out all the parameters if we find out that the two triangles are congruent. Okay, so I think you will be able to understand by these two examples for SSS criterion. In the next class, we'll see yet another example for the same criterion, SSS criterion, and we'll also move to the last criterion, which is right angle, hypotenuse, and one side criterion. Okay, so until then, keep revising, do as many problems as you can, do a mix-up of all the type of criterions, congruency criterions, so that it will be easy for you to visualize. Okay, so until then, keep practicing. It's bye from Manu. Thank you.